Hello everyone and welcome back to the lecture series of learning theory of automata and formal languages. So we are into unit number 1 and we are learning about the deterministic finite automata. So this is lecture number 2 and in this particular lecture we will try to learn about the concept of deterministic finite automata, its definition, its representation, and we will try to look a particular example on it. So in the previous video, we have understood the concept of basics of automata, the concepts of basics of finite automata. We have also understood few of the basic terminologies like strings, alphabets, language, okay? And we have also seen the basic formal description of a finite automata. Now we will try to look on to the main topics like what is the concept of deterministic finite automata. After that, we will look into the concept of non-deterministic finite automata, and like this, we will try to continue with all the machines until we reach Turing machine. Okay, so let's check today's agenda. What we are going to do? We are going to do the concept of deterministic finite automata mainly. Okay, mainly deterministic finite automata and its proper definition. Okay, maybe it's a formal description, maybe it's related to the concept of finite automata, that is deterministic finite automata. Its representation and its example. Okay, so let's check it out. The first slide says about the finite automata basic concepts, which we have already understood in the previous video. If students, you have not gone through the previous 2 videos, you can please go through it. Introduction 1 video and lecture 1 video, and this is your lecture 2. Okay, so in finite automata mainly we use the concept of pattern recognition. So basically, at the moment, at the very beginning, I have let you know that what is the current application of a finite automata. It's used in pattern recognition. But as of now, you put this particular concept and you just think of learning the concept of what is finite automata. Later on, we will try to relate with the application. Pattern recognition means you are trying to find out certain you are trying to find out, or you are trying to analyze, you are trying to match certain patterns from a particular analysis. Okay, so that thing in that particular context, like for analyzing, for matching, we use the concept of finite automata. But how? For understanding how, we need to understand what is finite automata and how it is working. Okay, so for the time being, you just keep this concept in your mind. Okay, application part. Okay, now let's go into the next point. It takes the string of symbol, which we have already mentioned in the previous video, as input. Okay, so it takes the string of symbol as input. That means whatever input you are taking, you are taking this input in the form of what? Strings. In the form of strings. Okay, now we will take this particular input and we will try to process this. And how to process this? We can process with the help of states. Okay, as I mentioned, changes its states. Okay, so this is another part. Okay, after that, some transitions will occur from one state to another state, and finally we will reach an accepting state. Okay, now the next point, at the time of transition, the automata can either move to the next state. As I've already told you, transition can go from one state to another state, or can be to itself. See, either move to the next state or stay in the same state. So this is the main point. Okay, so that means what we have understood, we have tried to understood that the automata will take the input in the form of strings, process those inputs in the form of states, and those processing of transitions can go from one state to another state or can stay to itself, and finally it will reach an accepting state. Got it? But some way or the other, if the string doesn't belong to the language, then what it will happen? It will not go to the accepting state, rather it will go to the rejecting state. So that's why I have mentioned here, reject state will be one state and accepting state will be the another state. Got it? So finally what we can conclude? We can conclude that input, okay, from the input we will do the processing with the help of states. Not one state, it may be more than one state depending on the language, depending on the string of the language. Okay, and then finally we will get back to the output. So output can be in the form of a accepting state or can be in the form of a rejecting state. Got it? So this is all about the basic concepts of finite automata. Now, only we need to extend this particular finite automata in two types: deterministic, non-deterministic. So let's check it out, what is going on in that particular topic. Now, before going into that topic, we should also understand the formal description of a finite automata. Formal description says that it's nothing but characteristics definition of a finite automata, or you can say the main attributes of finite automata. Okay, so finite automata generally comprises of 5 tuples. One is Q, sigma, delta, Q naught, F. Now we will try to check it out, what are these meanings. Q generally state for finite set of states. As I've already mentioned to you that there will be some set of inputs in the form of strings, correct? And then these input will be processed by through what? Through the states, with the help of states, and then finally we will be having an output. So output can be in the form of what? Can be in the form of a can be in the form of an accepting state, can be form in the of a accepting state, or maybe in the form of a rejecting state. Okay, so this is the hierarchy which every machine tries to follow. Okay, now if we want to take the input, again I am repeating, if we want to take the input, we have to take in the form of what? Strings. So that means these input will be taken as a part of one alphabet. Okay, suppose I say that I have two inputs, 0 and 1. So these are the two inputs. Definitely by using these two inputs we will form the strings. So that means this will come as a what? As an alphabet. Okay, I have already mentioned this topic. We have discussed this topic in the lecture number 1. So you can go back to that topic and you can learn it, like if you have skipped this particular topic. Okay, so this will come into the alphabet. So therefore this alphabet is nothing but what? Is nothing but number 2, that is sigma. It is represented by sigma, which consists of finite set of input symbols. So input symbols are this one. So that means this is nothing but 0 and 1. Just I am taking an example in order to relate to your to the context. Okay, then comes states. So states means one by one processing process. So where the states will come? The states will come to this particular point. Okay, in those states we need two important states. One is the final state, one is the initial state, and the other one is your final state. If we put logically, if we think logically, to carry forward any kind of work or any kind of processing, we need to initialize, and then in order to finalize that we need to process that to the final state, right? So therefore we need an initial state and one final state. So this is an initial state and this is a final state. Now students, you don't get confused that you need to use Q not only all the time. No, you can use another alphabet also, and here F, no, you can also use another alphabet. Okay, next comes transition function. Now this is the important part of your topic. So transition function is the one which will help you to understand how the processing generally happens from one state to another state. So the transition function generally for a particular finite automata remains fixed, that yes, my transition, or you can say this is the set of rules which generally gives you that how the processing of these strings will be done. Okay, now let's stop here. Let's stop this particular topic over here. Okay, why? Because this transition function I have to check for DFA, I have to check for NFA, I have to check for upcoming machines until we reach for Turing machine. So for all the machines, transition functions are different. That means you can say that this transition function is fixed for all the machines, and the processing will keep on changing depending on the language, or depending on the language given by the user. Okay, so this is all about the formal description. So if a formal description question arises, then we are having 5 tuples, finite number of states, finite number of input alphabets, input symbols or input alphabets, both are same, initial state, final state, and transition function. Okay, and these are the representations. Okay, let's go to the next slide. The next slide says what is the control, what is the configuration of the finite automaton model. So if we look into the finite automaton model, we are talking about the model. So we can discuss in this particular format. We just need two important data structure for configuring a finite automata. One is your input tape. Okay, another one is your finite control. So these are the two important data structure for implementing a finite automaton model. Why? See, first of all, I have told you that we will be taking the input. The same process we will be letting you know. Okay. So input I have to take. From the input, the processing will be done. Okay. And then finally, we will be getting the output. So this is the general configuration of every machine. Now this input, we need to put this input, or we need to store this input in some place through where I can do the read or write operation, right? So therefore, this input will be used or will be stored in the input tape in this format. Okay. Input I have already told you that we will be taking in the form of a strings. Okay. Now then processing, this processing can be done with the help of what? Can be done with the help of finite control. We are not concentrating on the output part, right? Output will be the one which we need to display to the user, not to us as a developer or as a designer. Okay. So we need to concentrate only on the set of inputs and the processing. Output will be done based on our logic, based on our calculations. Okay. So therefore we need two important data structure. One is input tape, one is finite control. And in order to process this scenario, for the finite control, we need a tape reader. As I have already mentioned over here, tape reader. This tape reader is the one which will read alphabet of the particular string one by one and then finalize the string, that whether it has been read completely or not. Okay. So this is the general configuration model of a finite automata. Okay. Now let's go with the upcoming slides. Next slide says the types of finite automata. If we look into the types of finite automata, let me show it to you. This is what already have been given to you, that finite automata is categorized in this. But actually, we need to look into this particular point. Finite automata can be divided into two categories. Okay, finite automata with output and finite automata without output. Okay, two concepts will be there. That means two machines will be there. One is your with output, another one is without output. Whenever we say with output, we categorize this particular part into again two types. One is your Murray machine and the other one is your Mealy machine. So these are the two categories of finite automata with output, which we will be studying by after 2 or 3 classes. Okay. Then finite automata without output is categorized into 3 parts: DFA, NFA and epsilon NFA. Epsilon NFA. Okay. So overall, this particular finite automata without output is nothing but this one only, whatever I have mentioned over here. Okay. Without output means we are not concentrating on the output part, we are rather concentrating on the final state or accepting state. But in the case of this finite automata with output, we are not concentrating on the accepting or rejecting states, rather we are concentrating on the output which is associated with states or maybe which is associated with the transitions. That I will let you know which one is associated with state and which one is associated with the transitions. Okay. So this is the general hierarchy of the finite automata. Okay. Because maximum of us generally does some kind of mistakes, we generally define that finite automata is divided into all these 5 cases. In some books it is mentioned, but actually we should know this proper hierarchy, that with output, without output. Then it is further segregated into these types. Okay. So let's check one by one. I will let you know how to start off with the scenario. We need to start off with first DFA, okay, then NFA, then epsilon NFA. Okay. After that, I will check first Murray machine and then Mealy machine. Okay. So this is the general hierarchy of understanding the machines for unit 1. After that, in unit 2, we will look into regular expression. In unit 3, we will look into the concept of grammar. In unit 4, we will look into the level 2 machine, that is PDA, and in Unit 5 we will look into the last level, that is Turing machine. Okay. So I will let you know in the upcoming lecture what is the hierarchy of the machine, that is known as Chomsky hierarchy. But as of now, for this slide, this is the general configuration. Okay. Let's move into the next slide. Next slide says the deterministic finite automata definition. Okay. Now this is whole and soul the entire part or entire definition part of your deterministic finite automata. So you can note down this particular points if you want. I am just giving you the slide as of now. Okay, you can pause the video and you can note it down, but I am just going into the brief idea of what is the DFA meaning is all about. See, first of all, we have already understood the concept of finite automata, right? In this finite automata, I have added or I have concatenated this terminology that is known as your deterministic. Deterministic means what? This particular machine is determined. This particular machine is having a particular concept of having a transition for a particular input alphabet, exactly one, not more than one, not less than one. That means if I say a particular state, okay, say suppose Q0, this particular state for a particular input alphabet, it will go to another state exactly once, not more than one, not less than one. Not more than one means what? For this particular input transition, it will not go more than one time. It will go exactly one time. So this cannot happen in the case of deterministic finite automata. Okay. So it is determined that for a particular input symbol, it will go to the next state exactly once, or not more than one, not less than one, or maybe to itself. That means either it can go in this particular format, or it can take a self loop over to itself. Anyone. I am not drawing both the things. See, I am not drawing both the things. You can take anyone, either this single transition or maybe to itself. Okay. So finally, I am again repeating only one particular line that is important for deterministic finite automata is that for every input, the deterministic finite automata is determined that it should have exactly one transition that will go to the next state or to itself. Exactly one, not more than one, not less than one. Okay. So this is the main definition of a deterministic finite automata. So you can go through all these points. As I have already mentioned, the second point is there is only one path for a specific input from the current state to the next state. Okay. And one more important point is that does not accept null moves. Why? Because I have already mentioned that for every input, there should be one transition, exactly one transition. Not more than that, not less than that. Not less than that means what? There is no transition. So that means null move cannot be accepted. Okay. Null move means null transitions, zero transitions. Okay. Or void transitions, empty transitions. So this is all about your DFA, deterministic finite automata definition. Later on, after completion of NFA, we will try to do some equivalence of DFA and NFA. But as of now, this is the main definition of DFA. Okay. Let's go into the next slide and check it out what is kept for you. Okay. Now next slide says the formal description of DFA. If you know the formal description of finite automata, it's exactly same for DFA, NFA, epsilon, NFA. Only the difference lies where? This one, transition function. The rest, everything is same. Now I will let you know what is the difference, what is the actual meaning of the transition function of DFA. Okay, in the previous slide, I have already mentioned that let's halt for the transition function. We will check later on. Now we can check it. Okay. Now see, we know about DFA that for every state, that means I have to take what? Q. For every state, for every input, that means I have to take sigma. Correct? For every state, for every input, there should be having exactly one transition that is going to next state or to itself. Next state or to itself will come across where? Q only, finite state of states. So it will go to where? To Q only. So that means I have to take this particular definition as your transition function. See, for every state, for every input alphabets, it will go exactly one transition to next state or to itself. So this is the transition function for DFA. When we will discuss about NFA, we will have what is the difference between the transition function of DFA and NFA. That time you will come across. Okay. So this is the transition function of DFA, and rest all formal description attributes are same. Q, finite state, set of states. Sigma, finite set of input alphabets. Q0 is the initial state, F is the final state. Okay. So this is all about your formal description of DFA. I hope it is clear to you all. Let's move to the next slide, and possibly this will come across with the last part, graphical representation of DFA. Now, if you look into the graphical representation of DFA, we need to understand how the machine or how the processing is being done, is being graphically represented. For that, we need the help of three things: state, then input character, then initial state, four things, and final state. Okay. State is represented with the help of a circle. Okay, or states are nothing but the vertices of that particular diagram. Okay, then whatever input alphabet we should put into a arc drawn from one state to another state, like this. If this is a state, if this is another state, then input character should be drawn in an arc, in a directed arc, and this can be the input alphabet. It is A, you can have any input character. Okay. Then initial state is marked with an arrow sign followed by a circle. So wherever a single arrow followed by a circle is there, that is the initial state. Okay. And final state is represented by a double circle. That is what it is represented. See, the state is represented by the vertices. Okay. And the arc labeled with an input character show the transitions. This one. Okay. Initial state is marked with an arrow. Okay. Final state is denoted by a double circle. Okay. So therefore, I can finally show you that how the diagram will look like. Okay. So this is state. State is represented by this one. Okay. Then this one. And then this is the one final answer for the graphical representation. Okay. Now, while depicting the particular DFA or NFA, we can represent in the form of either transition diagram or in the form of transition table. Okay. First, we will check all the time that how to design a transition diagram for a given finite automata. Thereafter, I will look into the transition table. Okay. So let's now look into the last slide of our this presentation. We will be looking on how to construct a DFA. But in order to construct a DFA, first I will not discuss in this video, I will not discuss about DFA, rather I will go with finite automata discussion. Okay. Because you should understand how to create a finite automata, then we will discuss about the DFA part. Okay. Now here we are telling that we need to create for the language of the string A, B, A. So this is the string given to you, and you need to construct a finite automata for it. What this finite automata does is that it will take an input tape. Okay, I will put the string over here. Okay, and a tape reader. A tape reader will be there, which will control by the finite control, and then it will check one by one. So it will start from here. Okay, and it will scan each alphabet in the string one by one until it reach from the initial state to the final state. So therefore, I have to take an initial state over here. Say suppose A, I have named as A, state name is A. Okay, first it will read what? It will read alphabet A. So that means I have taken a transition A, and this transition will go to another state, say B. This is the way you are going. Okay. Then the tape head reader will move from here to here. Now the next alphabet is what? A. Then again I will draw an A transition from state B to state C. Clear? A is read. Then again the tape head reader will move towards to the next index position, and that is what? B. So again from the state C, it will go to another state, say D, and this transition will be what? B. Clear? Till now it is not done until it reaches the end point. So B is read, then again the tape head reader will move towards to A. So A then means again on transition from D, state D to state E. Okay. This alphabet has been read, then again it will move forward. Again it will read the last element. Okay. A, and it will go to another state, say F. After that, the tape head reader will reach the final state. So that means there is nothing, the string has been completely read. So I can make this particular state as the final state. So that means in this particular format, I have read this particular A as a overall. Got it? So this is how we can do the processing of a particular string with the help of a finite automata. This is how we have constructed a finite automata. In the next video, I will show you how to construct DFA from it. It's exactly not a DFA. I can just for the meaning, if you have already understood the topic, it's an NFA. Why? I will discuss in the next video. So this is all about, I hope this is all about today's video lecture. We have understood the concept of finite automata. We have understood the concept of formal description of finite automata. We have understood the concept of deterministic finite automata, its formal description. And then we have checked how to design this particular finite automata. In the next video, we will come across with various examples on DFA. So thank you for watching this video.